Bismillah. Hello, welcome back. Last class we discussed what is a low pass filter and we discussed how applying an average low pass filter of various sizes blurs an image. And in the last class itself I discussed what is a low frequency, what is a high frequency, and what is a low pass filter, high pass filter, what is a mask, and what is a filtering. Just those who have missed that video, I repeat the things again. Frequencies of an image are measure of the amount by which the gray values changes with distance. A simple example. High frequency components are large changes in small distance, and low frequency components are little changes in the gray level. I will give an example. Let us take an image. Right now, if I want to see the matrix, see that this one 156, 153, there is a small change. Likewise, 153 to 155. Over this distance, the gray level value changes very little, 153 to 155. Therefore, these are called as the low frequency components, 159 to 159, 159 to 155. So all these are low frequency components. Whereas if I keep on searching in the entire image, if I see there is a major change somewhere, then say for instance if I take some values, pixel values, where there is a major change, say for instance here you can see that between 187 to 35, see that there is a major change in the gray level. So this one is called as a high frequency component. 194 to 69, a high frequency component. 92 to 84, a high frequency component. 17 to 18 is a low frequency component. 18 to 21 is a low frequency component. Alright, so all these things are low frequency components because there is a little change, and if we keep on going like this, then you can see that here, see that this one between 20 to 123, a change of the gray level is more, so it is a high frequency. 14 to 137, it is a high frequency. Then 137 to 143 is a low frequency. Probably there may be abrupt change, 14 to 137. This may be an edge, or there may be a major distinguish in the figure, because this pixel is 14 and this pixel is 137. All right. So basically the gray level, where major change is there, it is called as the high frequency, and where little change is there, it is called as the low frequency. What is a high pass filter? High pass filter, it allows high frequency components and eliminates low frequency components. High pass filter, as I said again, I think this high pass, that is high frequency components are passed, are allowed, and low frequency components are eliminated. Likewise, what is a low pass filter? The low frequency components are passed, are allowed, and high frequency components are eliminated. We saw a example where an average filter, it is a low pass filter which allows low frequency components and thereby eliminates the high frequency components. Alright, now in the case of this one, the filter, this is a 3x3 filter, and this is called as a high pass filter. Most of the high pass filter, the sum of all the coefficients will be 0. See that 1, 1, minus 2, 4, this cancels with 4, 1, 1, 2, minus 2, 1, 1, 2, minus 2. Therefore, the sum of all the coefficients becomes 0. High pass filters are used for edge detection, because edges are nothing but the high frequency components, because there is an abrupt change from one level to another level, then that is basically an edge. Now let us see how these edges, how these frequencies, high frequency components are shown. I have taken the MATLAB. Now I have taken this cameraman.tif and let us show that image. Let us show that image. IM show. I will take this one figure, comma IM show which image IM, and this I give the title. This is my original image. This is my original image. Right. So this is my original image. Right, I will take a 3x3 filter. Therefore, I will take the first filter, mask, F special equal to mask. Therefore, this is my mask. See that the sum of the coefficients will become 0. 1 cancels with -1, 2 cancels with -2, 1 cancels with -1. Therefore, this should be a high pass filter. This will allow high frequency components and it will filter, it will eliminate the low frequency components. Right, once I have the mask, now I apply this mask on this image and I get the image 1. And if let us see this image, IM1, and let us see this filter, this is my original image, and this one is the image which I got after filtering. See that this one is the high frequency components are shown. The low changes, see that all these things, the coat, the person's coat, they are almost same gray level, therefore they are filtered out. Where there is a major abrupt change like edges, see that in the building also these edges are there. And this one, because of this filter, see that basically this is 1 to 1 and this is -1 to 1. This is a filter which can filter the vertical components very easily. See that. So if you compare these two images, see that even though this building is there, only the vertical component is taken out. See that this one, all these edges, they are taken out. So this is the effect of applying the Sobel filter on this image. Now let us apply one more filter which is called as the Laplacian filter. Therefore here also the sum of the value is equal to almost 0. And now if I apply this filter on this image, even if I show this image, and this is the effect of applying the Laplacian filter on the image, this one. So this is also a full high pass filter. This one is the effect of getting a high pass filter Sobel, and this is the effect of getting the Laplacian filter. Here also the edges are almost taken out and they are shown here. Let us take one more filter. Let us take Laplacian of log U. So this one is the one mask, and this mask is applied on this image and we get image 1. And now let us show this image which is a Laplacian of Gaussian. Therefore now I take all the images for your comparison. This is my original image and this is the image when I apply the Sobel filter, and this is the image when I apply the Laplacian filter, and this is the image when I apply the Laplacian of log Laplacian of Gaussian filter. So all these filters have taken the high frequency components separately. The edges they have taken and they have shown at, and all the low frequency components where there is a little change in the adjacent values are filtered out. Where there is a maximum change between two adjacent pixels like the edges, they alone are shown out. From these three filters, it is quite clear that out of all the Sobel filters, Laplacian filter and Laplacian of Gaussian filter, I feel that the Laplacian of Gaussian filter gives more number of edges. It gives a very better filtering comparing to other Laplacian filter and Sobel filter. Right, so this one is a high pass filter. All the high frequency components are allowed and the low frequency components are filtered out. High frequency components are passed and the low frequency where there is a little change, they are filtered out. Alright, so this is a simple example of what a high pass filter and what is a mask and what are the various types of high pass filters and how the high pass filters is used to deduct the edges and other thing. Hope this would have given some basic understanding of what a low pass filter is and what a high pass filter is. In the low pass filter, the averaging value becomes the sum of all the values divided by 9, whereas in the high pass filter, since they tend to 0, all the prominent edges they are highlighted, and this is what we get in case of all the high pass filters. Right, in the next exercise we shall see what is meant by edges and how we can add edges and how we can add various types of noises and how we can filter it out. Hope this would have given little understanding, and let us continue in the next lecture. Please do comment on the video, please give some positive criticism so that I can improve, and please subscribe my channel. Thank you so much.